Okay, I think I'll start. I guess people will join when they can join. Thank you, everyone. Thank you for joining us in our Geothermal Energy in Residential Construction webinar. It's a pretty exciting event. We've got great interest in it, 500 registrants. So roughly we have almost 200 people on the webinar right now, and it'll probably be growing. My name is Leona Savoie. I'll be moderating this event, and I'm joined by some great experts to essentially debunk some myths that are swirling around in the industry as it relates to these technologies being incorporated into development projects. Geothermal by no means is a new technology. However, there's been some shifts over the past 5 to 10 years that have brought geothermal to the forefront to be considered as a tool available to developers and builders to meet regulatory and marketing needs in their projects. Some of these shifts include newer financial models, technological improvements, and means to execute more efficiently in the field to manage project schedules. This panel discussion is an opportunity for us to explore geothermal energy, how it works, how it is being implemented, and the perceived gaps in the industry with this green technology. And now I'd like to introduce our panelists. Firstly, Tim Weber is the co-founder and CEO of Diverso Energy, which is a geothermal utility company that designs, builds, owns, and operates geothermal assets in Canada and in the US. Tim has spent 16 years in the geothermal industry in a variety of roles and brings a wealth of experience in the technology and the business model for geothermal and multi-residential buildings. Next is Bram Atlin. He's a principal of Smith Andersen, one of Canada's leading national consulting engineering firms. Bram leads S&A's multi-unit residential building team, which specializes in mixed-use and large residential tower developments. Next, we have Jeff Wilkinson. He's the vice president of Wilkinson Construction, a construction management company with over 45 years of experience building projects across Canada. With expertise in mid-rise and multi-residential projects, Wilkinson has been involved in 6 geothermal projects in the GTA to date, and is always looking for new technologies that can be applied in construction in a practical and cost-effective way. Finally, I'm Leona Savoie from Hullmark. I'm the Senior Vice President of Development, and I have over 20 years working for developers and builders. My role is primarily executing on the front end of projects to get them permit ready. This includes considerations of all technologies required to meet regulatory and marketing needs of a project. And in the context of today's discussion, this would be ramped up code requirements to meet energy targets and planning requirements, such as the Toronto Green Standards. I'm by no means an expert in this topic. However, over my career experience, from the owner's perspective, geothermal has typically been quickly dismissed until as of late. And we can delve into the reasons for that in the discussions to follow. Guys, thank you for joining us, and we look forward to an engaging panel discussion about geothermal energy. As for the format of this discussion, we will be chatting amongst ourselves for roughly 45 minutes, and we're opening up for Q&A for the last 15 minutes. Please submit your questions in the Q&A section, not the chat section, otherwise they won't be received. And they'll be directed to me when the time comes up. If you have a question that's directed to a particular panelist, please note that person that you want me to direct it to. So on to the questions. First of all, Bram, can you introduce the topic by telling us a little bit about geothermal energy, how it works, and the benefits with this green energy?
Yep, I can do that, Leona, and thank you for having me here today. So geothermal energy, it's a renewable energy source. It refers to the thermal energy that's either stored, injected, or extracted from the ground. In buildings, we use it as a heat source or heat sink. And the simplest way to think about it is it replaces part or all of your heating or cooling plants in a building. Like those conventional systems that we all think about, whatever they may be, we extract or reject energy. And instead of, doing this from fossil fuels, which is called the traditional way, or rejecting the heat to the sky, the ambient sky, i.e. cooling, geothermal does this using the earth beneath the buildings. So, we generally associate geothermal as a means to reduce or eliminate in building operating carbon, i.e. reduce burning of fossil fuels. And it also tends to be associated with replacing some of the physical space that a traditional plant takes up in your building. From our perspective, being the consultant's perspective, it's really, I like to think of it as a tool in the consultant's toolbox, and it has many great applications, none other than, many applications in the multi-unit and mixed-use residential industry.
Thank you, Bram. Tim, how is this technology being applied to condominiums and rental buildings as opposed to traditional utilities? And how has this green technology actually become affordable over the years?
Yeah, great question. Thanks. One of the challenges of geothermal is the capital cost is high, but the energy cost is low. And the problem facing condo developers these days, no surprise, is costs are going up. Development charges have more than doubled in the last few years. Trades have gone up by, in many cases, double digits. Land is very hard to come by, so of course it's gone up. So, their pro formas are being squeezed. They're under tremendous pressure. They've got competing pressures that they have to deal with. So to introduce geothermal into that environment is clearly a huge challenge. And in many cases, the only way to recover that investment is to increase the sale price of the units, and that, of course, is a non-starter. So that's essentially why the third-party ownership or the utility model was created, was to mitigate that issue, solve that problem by eliminating the first cost, turning it from a capital expense into an operating expense. The condo developer can offload that cost to the occupants, and it's cost neutral for them. They're able to take advantage of the technology, meet green standard requirements, move equipment off the roof. So they get the benefits of geothermal without the impact of that first cost on the budget. Rental buildings, of course, are a little bit different. Their perspective is different. They're looking at the long game. And so for them, they're trying to find that delicate balance between, they still have budgetary issues. They still have to work within, the limitations of their lenders, but they're also looking at that long-term NOI or net operating income impact, which of course drives the, asset valuation. So, there's some creative new financial models that have been created where you still take advantage of the third-party ownership, but kind of like buying down a car lease, you put a deposit, lease payments are reduced, so they still get to take advantage of operational savings, but that first cost now stays, keeps it much lower, so it still works within their existing construction budget.
Thank you, Tim. I can validate, some of the comments that you've made, and it's great to hear that there are options out there for developers and builders, because we all know that not every developer is created equal, and their cost of capital is different, from developer to developer. I can personally say that we've been working on 2 rental projects, one being a smaller boutique 45-unit project, and one 230 unit project, again rental, with the long term in mind. And I could say that both models are very different. One definitely makes sense, and we're definitely jumping into making the investment, and on the other side, the site constraints on the larger project is proving to be, we're just trying to evaluate the cost benefit analysis right now, and what the ultimate payback will be. Now, on to the next question. There seems to be a lot of swirling misconceptions around the implementation of geothermal energy. Why are these misconceptions out there? What are they, and how can we address some of the myths? Can we start with Tim?
Yeah, sure. There certainly are a lot of misconceptions. I could go through a lot of these. I think the top three for me, one would be the impact on schedule. That seems to come up a lot. And, critical path, of course, is sacred for developers. Projects being delayed can have a huge impact on the overall economics. And what's happened over the last few years, not so much a innovation in technology, but more so innovation in the drilling process. Drillers have become more focused. They've gotten better, which means that the speed has increased, so they're able to drill a lot faster. I think the biggest impact is the ability to drill underneath the building and pre-drill before the project starts. So they get in, they get out, they demobilize, which has had a huge impact on that schedule, on the impact on schedule. The other thing that they've become much more sophisticated. They understand the importance of integration and sequencing, and if the site permits, in many cases they're able to drill at the same time as shoring and excavating. So that takes that impact, which used to be several months, and in many cases now it's down to just potentially a few weeks, depending on site conditions. Another one, and I think this is a big one, it's the idea that geothermal, if you put in, it just works forever. And Graham mentioned earlier, the ground is like a thermal battery. Energy is going in the summer, BTUs are being taken out in the winter, energy in, energy out. It's thermal storage. It's pretty rare to find a building that's perfectly balanced. So inevitably what ends up happening, if too much energy goes into the ground, it'll overheat. So the bore field needs to be managed. And it's finding that delicate balance about, making sure that long-term, the energy in and energy out is equal. And if there's too much, what do you do with that? And if it's not managed properly over time, it will actually overheat.
Tim, I just have a follow-up question for you.
Sure.
I'm sure you've encountered this in some of the projects that you've worked on as well. Say, for example, you have an environmental remediation program that you need to employ before you even break ground. Are there ways to work around the drillers and all of the work that you need to do for, say, for example, injecting into the soil and letting it sit for a while, while the project sits and lets the solutions, the environmental solutions, do their thing? Just curious.
Yeah, it depends on what what remediation is required and what the contaminations are. We've yet to see a project where contamination has, been a non-starter. So depending how far down it is and what it is, we can deal with that during the drilling. In some cases, the drilling spoils might be separated and taken away and dealt with that way. So it really just depends, but it's very rare that would be impede the project.
Okay, great, thanks. Jeff?
Just to jump in there, Leona, we've done, of the 6 we've done, 2 have been on contaminated projects.
Oh, great.
It hasn't had any impact.
Mm-hmm.
Yeah.
Okay. Jeff, did you want to elaborate on some of these misconceptions?
Sure. I guess maybe I can give my comments from a construction perspective. I find so based on the experience I've got, geothermal is incredibly simple. And I think that it's important for people in construction to understand that and hear that. And I'm not minimizing the geothermal engineers or Diverso or what, the drillers' work. I think it's progressed to the point where it's made the construction manager's job quite simple. So I guess, recalling back to the first project that we did with Geo, I had a lot of things kind of going around in my mind. You've got these crazy deep boreholes sitting under the building potentially. How does that affect soil, groundwater? What about our excavator and under slab services? There's so many reasons really to totally dismiss it. But I found, we went through every project we've done, we've had absolutely no problems. And that's, partially probably due to the simplicity and partially probably due to, the pre-planning and Diverso's work, and Geosource was the driller on the odds we've done, and they did a great job. So, anyways, that's been my experience. I mean, going back to the simplicity of Geo, what I did was I put together a couple of pictures there's kind of I was going to walk through the process of how it ties in. Maybe I'll quickly go into this. I mean, here in this picture, this is a project where we were drilling actually outside the base, you know, the boundaries of the building, which makes actually geo much simpler from a construction perspective. But you know, the key piece, I think, for us is all the work is done from the surface. So you know, whether it's below the building or it's outside the building, the driller comes in and he does his work from the surface. You don't have to worry about lowering the rigs into the excavation. This work could be done ahead of time. Here, it didn't affect our construction whatsoever, so it was outside of the building. So the boreholes themselves are kind of drilled basically from the surface to the bedrock. They're drilled with a metal sleeve, casing, I guess. That's the top left picture, and the drill goes. You know, you drill down to the bedrock, so you have to use that casing, and then from the bedrock down, you drill into the rock, and they go down. These holes will go down, I don't know, anywhere from 650 to 850 feet or so. And once that hole is drilled, you kind of insert that geothermal pipe. That's the black plastic pipe there. You push that down into the hole, and that pipe is actually two pipes with a U at the end of it. So it's supply and return. So that gets pushed down to the base, and then what happens after that is you basically grout it, which is you fill the hole with like a bentonite material, which seals the hole, seals everything together, and I think bentonite basically swells with water, and it also improves the conductivity between the pipe and the soil or the rock. So one thing I should say is you can go to the next slide. Maybe that's the video. I guess before we get into that, one thing that's key, I guess a key piece to this is when you drill those holes and you push the geopipe in, after you've inserted the geopipe, that pipe is cut. That black pipe is cut about 12 inches from the down below the surface, below the surface of your excavation. So when you go to excavate, there's really nothing in your way. You were totally uninhibited by the fact that there was these holes drilled from the surface. So this video is just kind of showing a process we were doing, a site in Brampton, just showing you the drill rig. It's kind of a muddy process. There's quite a bit of mud and water, but other than that, that's the only thing that really needs to be managed. So let's just see here. Let's go to the next slide there, Ad, and we'll. I just wanted to talk about the laterals. So you've got your holes in the ground. Basically, you've done your excavation. The driller goes in and he actually locates all the location of all the boreholes before you start your excavation. He locates that. Then when you go to you can start your. At this point, you can start your footings, and you could do your underslab services, and then after your underslab services, the driller or the geo guy will come in and he will tie your all the pipes together with laterals. So laterals being these black pipes, they kind of tie all the boreholes together. So you got your supplies and returns. They're all coming into there, and they go under the slab, under the drainage layer, and then you're running them all into one room, the geothermal room, and they come up just like that in the room, and you've got basically your supplies and your returns, and the supplies will be tied in with one header, and the returns will be tied in with one header. So maybe I'd go along to the next. Move along there, and that was just a project in Burlington. So that's again showing the laterals and how they're running in the excavation. You can see there that we've already done our underslab services. So this is just prior to backfilling our granular and getting ready to pour our slab. So you can move along from there. Same situation. That's a project we're doing on River Street. That's same setup. The pipes are coming out of the ground. And yeah, that was what I wanted to go. That basically shows you a typical geothermal room once you're complete, slabs have been poured, and the headers are tied together and insulated here. Just a couple of pumps to move the water kind of glycol mix through the boreholes. And then on the other side of this, you tie into a heat exchanger, and that connects to your HVAC system. So really almost no space. And it's quite simple. It's almost, in my mind, it's simpler than lifting a cooling tower onto a roof of a building. So that's my opinion.
Bram, do you have anything else to add?
Yeah, so thinking, this is about misconceptions. I would certainly echo Jeff's comments that it's in fact simpler. The misconception is that it's more complicated, and the opposite is true. But I do have to put a caveat that, some fundamentals need to be understood for that to be the case. And, some of those fundamentals are sort of a change of focus. And in, one example is we tend to focus on peak. How much heat do I need? How much cooling do I need? Peak. And I think the focus needs to put on the annualized load. And the other part of that is that the engineering community, we can't be too conservative. That's a mentality that not only comes from avoiding issues, just having something too big, but it also comes from a mentality or a culture of or I should say a marketplace where gas heat is cheap, both the equipment and the utility. So there was very little downside. We weren't incentivized to really dig in. The other misconception I find is people say it doesn't work because the ground is cold. And I'm not going to go into a whole technical explanation of that, but yeah, we're heating the building with freezing water, and it's possible. I would say thinking about the last part of misconceptions is that there's this thought that geothermal can't be compatible with all in-building systems. And I can say it certainly can be integrated with any building system. And when we talk about residential, it tends to boil down to 4-pipe or 2-pipe fan coils, heat pumps, water-cooled VRF, among a few others. And it can be integrated with any of those. And there is some truth that it maybe lends itself more naturally to one or two. You see more heat pump jobs associated with geothermal, but really you can use this source for anything. And then it integrates very well with the rest of the building. You can look at any kind of low temperature system and have this integrate into that.
Okay, thank you, Bram. Obviously, there's a lot of benefits to embracing geothermal energy from a saving the earth perspective. But what are some of the benefits of using this technology from a development perspective? Bram, did you want to start off on this one?
Sure. So, we've always thought about energy efficiency, and more recently, we're thinking about operating or even embodied carbon. The truth is that the implementation of certain technologies really doesn't pick up steam until it's no longer bleeding edge, and more specifically when it's mandated by some kind of legislation or code or standards, and that day has come, right? So the building code. If we talk about local standards in Toronto, but it would apply to many municipalities and many codes. In Toronto, we have Toronto Green Standard, and it's actively promoted this through the energy targets, but also more directly by mandating a reduction in carbon intensity. And we're going to see that we're going to see the first major shift in building mechanical technology for SPA applications made after 2022, but then it becomes even more stringent in 2026 and in 2030. On sort of from the development perspective, you got to talk about the elephant in the room. Whenever I walk into a meeting, we talk about geothermal. It's can I get my roof space back? Can I find another use for this very valuable space? And from the client's perspective, sure, we have to look at that advantage that we can replace traditional equipment or displaced traditional equipment and move some of that off the roof, not all of it. And it's a very hot topic, and it has a lot of nuances, and you have to start getting into zoning bylaws and getting in there early politically and strategically to make that happen. But there is a lot of potential, and I think we'll see that in the future, even if we haven't been able to unleash that advantage in the past. A final thought is that, you know, on geothermal, when I really start to think about buildings, and this would be similar to other technologies like central plant utilities, mechanical systems like construction want to be built from the bottom up, and we don't talk about that enough. But you know, they want to be from the bottom up, and this is a way that you have that happen, right? You build your source or your storage at the bottom, and then you build your plant up, and it has other advantages depending on the size and complexity of early occupancy discussions, as well as things just follow nicely instead of getting to the top and then there's a mad dash to finish elevators, to finish boiler rooms, to finish some of these critical pieces that couldn't even start until concrete's cured.
You know, I can personally attest to the fact the last two projects I worked on from a zoning perspective, the shrink wrapping that the city wanted to employ on the mechanical penthouse was just crazy. And what a lot of people aren't talking about is with the ramped up TGS requirements, a conventional mechanical system or setup is commanding much larger space, you know, for mechanical penthouse rooms, and actually the 5-meter cap that you typically see, it's actually being pushed. So if anything, this is also another reason that's forced us to look into geothermal in a couple of our projects, or possibly Enwave in another one, but was this planning constraint that was imposed upon us. Can you speak to maybe some of the operational savings that a developer may see along the way, or add to this conversation?
Yeah, and I think, you know, that's maybe another misconception as well, is there's often an over-index on operational savings. And I think, you know, the financial benefit of geothermal definitely transcends just operational savings, or more specifically energy savings. And, you know, if we start with condos, for example, you know, a lot of the projects we're involved in, they're actually seeing a reduced upfront cost because they're displacing the boilers and cooling towers. There's, you know, obviously a capital savings there from the equipment, but to Graham's point, if we can free up roof space, that's additional amenity space that could help them with sales and marketing. Or there's just the idea of, you know, a low carbon building. It's an opportunity to differentiate themselves against other developers, other projects in that area. So there's the capital savings, and that's obviously using the third-party utility model. Cost of the geothermal disappears, but they also get the benefit of the displaced equipment. Then looking at it from an operational standpoint, it's important to look at that holistically as well. When you displace a cooling tower and a boiler, it's not just the energy. Condo cores have to carry a reserve fund for depreciable assets, which of course the cooling tower and boiler are. So that's a capital reserve savings they'll see on an annual basis. There's water, there's chemicals, there's maintenance, there's repairs. So when you add all of those things up, it's really about the sum of the parts. And that's the total operational savings of geothermal. Rental buildings are different as well, you know, whether it be office or multi-res. They're looking at it again, it's long-term. It's really about that asset valuation. It's about protecting their investment. And I think what we're seeing now with these policy changes, they're looking at things very differently. This is about making sure the building they're putting up now is still relevant in 10 or 15 years. So it's almost a form of future-proofing the building. It's about hedging against future carbon taxes, energy costs. And, you know, for example, if you look what's happening in New York City right now, they passed something called Local Law 97. And as a result, there's buildings that were built 10 years ago that already need to be retrofitted. So the idea of, you know, having to retrofit a building in 10 years to comply with local standards or to make your building relevant, you know, that's not of interest to any developer, of course. So this is really about future-proofing the building, which is just a prudent thing to do for any, you know, long-term developer. And then there's also tenant quality and tenant retention, and that's more a case of an office building. So it's potentially driving revenue as well. So they get the benefit of operational savings and potentially a bump in their revenue at the same time.
Agreed. Yeah. Thank you, Tim. Jeff, on the cost side?
I wanted to jump in on one thing Tim said about the mechanical penthouse. I think that the impact of the elimination of the mechanical penthouse is probably greater than many people would just intuitively estimate. The obvious savings, obviously, is the cooling tower and the walls that go around it, but I think the change from cooling tower to geothermal, you go from a very mechanical solution to much more of a passive solution, and that mechanical solution, it's just got a whole bunch of bag of issues with it that we're constantly having to design around. So I think the noise is a big factor. Noise in from the outside and from the inside. You know, we build a lot in mid-rise residential, which are set into neighborhoods, and you've often got a big cooling tower right next to the houses adjacent. But then also the noise from the inside. These cooling towers are on the penthouse levels, and so your most expensive suites are beside your most noisy equipment. So then you've got to treat acoustically all the walls, the floors, to try to mitigate that noise. I think the vibration has to be addressed. Obviously, there's a floating floor that needs to be installed. Isolators. There's a lot of ripple effects here. I guess the last thing is the cooling tower is heavy, and you know, we try to look at all sorts of different structures for buildings, especially mid-rise. You kind of got to optimize your structure, minimize your loads, and get it as light as possible. And throwing a massive piece of equipment on the top of the building is pretty much the last thing the structural engineer wants to do. So yeah, that would be my comments on the mechanical penthouse.
Okay, great, thank you.
Yeah.
Okay, so there's obviously some key pieces in terms of cost savings and efficiencies. What about the downsides? Where does geothermal not work in a project? Bram?
Yeah, so I'll go back to one of my first comments, which is, you know, it's just a tool in our toolbox. It's not a one size fits all, and we gotta, you know, we can talk about it's the best thing, you know, and it's the greatest thing, but it's really a tool in our toolbox, and it's a pretty important one as we look forward. So it doesn't fit everywhere. You know, some examples that come to mind are, you know, the ratio of your site area versus your floor area, i.e. the tall and skinny, right, buildings. You might not have enough physical area under the building if it's lot line to lot line to get enough meaningful capacity in there, right? You know, waterproof foundations aren't without their challenges. It's not a it doesn't sort of become a no-go, but it is a challenge, right? And sometimes it can really put the performa sort of out of whack in some cases. As well, you know, if you're really just going to look at first costs and you're not using these creative financing models, you could, you know, stumble on that hurdle of, you know, the first cost and trying to compare that to operational savings over some meaningful term. And so I would just kind of sum that up by saying every project has its requirements, its needs, its wants, and we're finding geothermal checks a lot of boxes as we look forward in the residential community, but it doesn't check them all.
Tim?
Yeah, I think you know, the technology itself, there's really no size limitation, whether it be on the low end or the upper end. You know, we spent many years putting geothermal in residential homes, you know, even 1,000 square feet. So that's really not an issue. For the financial model, because there's, you know, baked in fixed costs, there is a certain economy of scale required, and we typically, you know, like to see projects 100,000 square feet or 120 units and up to make the economics work. On the upper end, I think to Bram's point, there really is no limit. We're working on projects now that are in excess of 1 million square feet, you know, large master plans, and it really comes down to that ratio of the size of the site versus the GFA of the building. But in cases where maybe that ratio doesn't work out and it is that tall, skinny building, you also look at the client's motivations. And if, you know, reaching, you know, TGS tier 2 or low carbon is a priority, you know, there are workarounds for that. And we always first try to integrate the equipment that's in the building, snow melt, maybe it's domestic hot water preheat. What do we do to augment that bore field to make it work? And if that doesn't work, you look at hybrid. You put in a cooling tower potentially to augment the cooling tower, or to augment the geothermal. And as long as the economics still work and addresses those carbon and energy targets, there really is no limit to the size of the building.
Okay, great. Jeff, do you have anything else to add?
I guess just on the downsides, I think the first thing that comes to many people's minds, I guess in construction, would be the schedule, and how do you kind of manage that through. I think there's different circumstances for each project, and you can kind of manage that one as much as you can. Like that picture we saw earlier with the geo bore field being outside the building envelope. I mean, that takes everything right off the critical path, and that can be done at any time. That makes it really easy. Where you've got a lot line building and the bore field has to go under the building, if the project can be planned such that the boreholes could be done in advance, that would be big. So you're totally, the construction schedule would be totally unaffected in that case. And I guess the one case where you've got say buildings on that property, you don't want to demolish them, and then you got to go in and do your geothermal when it's hitting the critical path. I think it's just managing that and potentially overlapping some activities with respect to shoring and geothermal drilling could potentially be done if the site was large enough. But that's the only impact or downside on the construction schedule.
Okay, great. So geothermal seems to be gaining momentum in the industry. This isn't just for niche developments. Many of the significant developers are starting to look at it. So Bram, could you tell me, why you think this is actually occurring?
Yeah, I can. As a mechanical consultant, aside from the basic assumption that our systems will work and you'll feel comfortable, we've done our job well when we're neither seen nor heard. And I think geothermal helps with that, just as an aside. But, the truth be told, I think the reason it's gaining so much momentum is we're not on the bleeding edge anymore. I think there's been enough successful projects that, you look to your peers, and I'm talking to you, Leona, you look to your peers and see that it's happening. And you say, well, if it works there, why doesn't it work here? So that conversation's shifting to prove to me it works. And now it's, why wouldn't we do it? Why? So I think there's that. And then also, I think, up to now, the residential, specifically the mixed use residential market, has sort of had a do as we've always done mentality for a lot of good reasons, right? There's efficiencies that are needed. There's systems that have been proven to work, and you rinse and repeat a pro forma and it makes sense. But, things are a lot different. Like even in my career, just focusing on mixed use residential and multi-unit residential, they're getting really complicated. And so I think, that in tandem with, some of the legislative reasons we talked about, TGS and other codes, we can no longer do as we've always done. We need to find a solution for the project, and this is fitting that. We've also seen, it has great uses. Some examples of that is it has great uses in certain scenarios where you have true mixed use, office with residential, right? And we can, geothermal can help share that energy around. We've also seen it work really well with trying to get low-level plants. So if you have an office building, 10-story office building and a 50-story residential tower above, we're looking at some good applications where geothermal can, at peak, can serve the commercial component, and then on an annualized basis, you can share energy through the whole facility. And it got rid of a dedicated low plant where, we don't want to be seen or heard. We don't want to put those offensive cooling towers and boilers at low level 10 feet away from someone's window. And then I would just also say, as we see things evolve, mostly driven by energy and carbon reduction initiatives, geothermal is very complementary to a lot of things we're already doing and things that are coming up. It's very complementary to snowmelt. It's very complementary to other like ambient or low-grade heat technologies like wastewater heat recovery. You know, look out for that. You'll hear that on, you know, jobs moving forward. That uses the building's waste system and actually recovers that heat. Domestic hot water preheat, and then also, I would be remiss to not mention resiliency. It is, you know, it has a place in that conversation. And if you've been involved in any institutional residential buildings or institutional developers doing purpose-built rentals, you know how much air the topic of resiliency takes up.
Great. I can personally, you know, say that before we embarked on exploring it in our projects, I gave a few friends a call, you know, who I knew had actually just finished some projects with geothermal in it. And, you know, like you said, it's like the more momentum, the more trailblazers lead the way, then I think the momentum is just going to pick up, which leads to one of our last questions. So we've heard that the geothermal industry is on track to double for the next 5 years. Can you tell us what the trends are that you're seeing from your perspective and what we should be keeping an eye on? So maybe start with Jeff. Shake things up a bit.
Yeah, sure.
Yeah.
I think the trend we're seeing is, because it seems to be getting traction in the industry, is there's an increased number of players in the industry. And that inevitably will, you know, drive up competition and probably drive down prices. I think that's just, you know, a natural effect. I think what struck me though about geothermal as we got into it is the industry is so small. And I think it's that way for a reason. It's a really specialized kind of area. And for that reason, I think you have to be really careful as to kind of which players you're going to. So I think it just needs to be properly vetted. I think there'll be more competition, but you have to kind of rely on the specialists in the industry that have local knowledge. And that's why we're talking to Tim and Bram today.
Tim?
Yeah, I think we've definitely seen a huge change. The last few months specifically, there's far more activity, and I contribute that to a few things. You know, I think first to echo Bram's comment, you know, historically the industry has been slow to change. They have a formula that works, and they're resistant to change that formula for good reasons. You know, $150 million projects, you need to make sure you use a formula that works, that equals success typically. The problem is that formula is now, I think they're recognizing it's broken, and they're in a little bit of a adapt or die situation where they see changes coming, and they can, you know, larger developers don't want to be caught flat-footed, so they need to figure out, how do we adapt for this change now? How do we make sure we're ready when this change comes? And, you know, when you look at the geothermal market, you know, to Jeff's point, it has been a bit of a cottage industry in the past, but that's changed. There's a lot of history. There's, you know, dozens of, you know, operating buildings that have been in operation for, you know, 10, 12, 15 years. And I think when you look at the market, you know, if you look at the law of diffusion of innovation, for example, we're now kind of shifting from that earlier adopter stage to the early majority. And I think for larger institutional developers, and that's the shift we've seen. Historically, it's been the small to mid-size. Well, now we're engaged in a lot of the larger institutional developers who are the risk-averse developers, but they recognize the proof of concept is there. They know it's time to change. And I think the other thing they finally have recognized, which has allowed them to come around, is that the idea of being environmentally sustainable as well as being profitable, those are two things that no longer need to be mutually exclusive. And if they had to choose between one or the other, I think we know which one they would choose, but they no longer need to choose. So that's kind of opened them up to technologies like geothermal. And the biggest one, of course, is just policy changes, obviously, and that's really forcing the hand. And, you know, what we've noticed internally in the last couple of months, the conversation has shifted to, oh, why should I do geothermal, to why should I choose you? And what that tells us is they're actively pursuing the technology. They're looking at it, they're doing it, they're treating it like any other technology. Now it's just about finding the right application with the right partner. So that's a significant change in conversation.
Bram, in like 30 seconds or less, can you add anything else?
Yeah, sure. I was just going to say, we're seeing that every job is at least talking about it, and just kind of talking about the so what of this. I think this last question. So what? Why? The consulting industry, we need to evolve and pull from our past experiences across different industries and building typologies as things get more complicated, and it just can be the right fit. Jeff made me think of my last thought is Jeff made me think that a few developers weren't really required to do geo on some past jobs, and they did it to get ahead of the learning curve, vis-a-vis the carbon pricing that's coming up or codes that's going to mandate to do them. And so we're seeing a lot of that. And that's why I think it's really going to start to pick up and double, as you were suggesting there. And to me, it really comes down to the right solution, trying to fit. Traditionally, in some cases, the first complicated jobs came up and we tried to fit a square peg being the conventional systems through a round hole being the right solution, whatever that may be.
Mm-hmm. Well, just to wrap this question up, I personally believe it's over the next 5 years, it's going to more than double, the geothermal traction, just from the sheer fact that there are a lot of more institutional players getting into the development game and rental housing product. And they all have ESG mandates, which is going to, this will be top of mind, how are we going to escalate or elevate our buildings from a sustainability standpoint? And if anything, the institutional players will bring along the other developers just to stay competitive, in my humble opinion. Okay, so on to our last question. Thank you for all the great insight, guys. Jeff, it's been an engaging discussion with everyone, but could you maybe wrap up today's discussions with any further thoughts?
Sure. I guess, one of the main reasons we decided to put this webinar together was we noticed there was kind of consistent and similar questions coming from developers on this topic. So, it was helpful to kind of, get the full rounded discussion by all this, the experts in front of them. Our company, we specialize in multi-residential kind of mid-rise, and multi-residential, I think, is one of the most risk-averse industries has got to be out there. Conventional, very slow to change. It's just been my experience as long as I've ever been in residential construction. What strikes me a little bit about geothermal is how simple and old the technology actually is. It's been very simple to implement. And so that was the one thing. I think one thing that I think it's really important for anyone who's considering geothermal is just not to underestimate the pre-planning. By the time that we're involved and potentially making this recommendation, it's often difficult to actually implement. Much easier if it had been considered much earlier. Even the same with Bram and Tim. The decisions or the exploration has to be done early. There's so many pieces that are impacted when you go down the geothermal road. It impacts building design and coordination. It impacts your sales documents, even your negotiations with the city, potentially TGS stuff, operating budgets you're putting into your agreements of purchase and sale. So that feasibility study need to be done early. But in my opinion, it should be looked at on every building. It's a simple and valid mechanical technology. So
Okay, thank you.
Yeah.
This concludes our discussion. I think we covered a lot of territory. Thank you, guys. I'm going to move to the Q&A. We roughly have 8 minutes. Might go a little bit over. Just for the benefit of everyone on this webinar, this is being recorded. So if you want to go back, and just by request, we can provide you a link to the recording of this event. So we'll move on to the first question, and maybe for any of you to answer. What if a whole property is a raft foundation with 3 stories below grade? How do we bring the piping down without puncturing the raft or waterproofing? And my team asks this question all day long. And in the world of groundwater management, and especially in the city of Toronto, this is top of mind, especially for a building that you don't want to hand off to a condo corporation. It's a building that you want to hold on to forever. So open it up to any one of you to answer.
Maybe I'll start, but maybe you guys can jump in because I don't have the only opinion here. But just kind of going back to that description that I was talking about of how it gets done and how you drill from the surface and how you clip those geothermal loops 12 inches below your excavation. That works with a raft slab. Same basic principles. I think with a raft slab, you're just potentially running your laterals, your laterals below your raft. So maybe you're a little deeper, but I don't see that any different than a conventional building on strip footings.
Yeah, like Tim, you go.
Oh, sure. Just to keep it quick, I think, we've done a lot of projects with raft slab, and I think the first thing to look at is why is the project going with the raft slab? If the water table is higher, there's under pressure. There are alternatives. We can either penetrate the slab and waterproof, or we have cases where we'll come up and around and go up at a higher point. So there's a controlled entry point, or we've got projects where they build an alcove and we go up and around and maybe come in at P1 instead of P3, or P3 instead of P1. And also a controlled entry point, and it's above that water table. So, project specific, but I wouldn't let a raft slab deter anyone from thinking geothermal is not still a viable solution.
I'll move on to the next question. Are there any environmental concerns related to extracting geothermal? Say, for example, I think there's a rumor out there that if it's not balanced properly, you can freeze the earth. Throw it out there. Maybe Bram?
Yeah, I mean, I can start the discussion. So I often make the reference that a geothermal field is a living, breathing thing. And I think there is a maintenance of the field, not the physical maintenance you're thinking of valves and pipes, but the maintenance of thermal energy in and out and the temperature trends. Like the first thing you do is on the design side for us is we align ourselves with the geothermal engineers, and we look at the trending and really what that is how the temperature of the field changes as we use the energy inside the building and how we use the energy. So it's not really a myth. It is true that one of the things that's a bit different is that you have to manage that energy in and out, and there's many ways to do it. And I touched on it in one of the previous responses where it doesn't need to be always a supplementary cooling tower or boilers to manage that discrepancy. You can creatively use other things inside your building like domestic hot water preheat or snow melt. Snow melt is effectively a cooling tower in off season in some cases if you want to run it that way. And you could use your other things like makeup air conditioning and tempering is like 25% of the load in a typical residential job. So by switching that on and off geo, like having that ability, if you're not necessarily zero carbon, could really give you the lever you need to ensure you're balanced.
Okay, great. What is the life expectancy of geothermal systems? What maintenance is required to ensure systems are operating as designed through its operational life? Maybe Tim?
Yeah, sure. That's an easy one. The life expectancy is, it's almost infinite. The pipe itself, it's called high density polyethylene. The only thing that breaks it down is UV rays, which clearly that's not an issue when it's underground. So the moving parts, there's pumps, circulating pumps, which, last as long as any other pumps, but the infrastructure itself will be there longer than the building itself, probably.
Okay. Another question maybe for Tim. Can you drill under an existing slab or garage in an existing building? Say, for example, there's a condo retrofit.
Yeah, retrofitting. Yeah, it's a good question. We've done some projects where we've, looked at angle drilling from the surface beside the building, and it can be done. There's challenges involved with that, but it's certainly possible. And as far as drilling underneath the building, I know, there's technologies being worked on, and it's progressing to, low level drilling or short drill rigs that you can drill within existing buildings. But the majority of the projects right now are in new construction just because it's simpler, it's easier, and it's lower risk.
or major intensification or densification projects where you get access to it as if it was new construction, right?
Yeah, and retrofitting, we've been involved in lots of retrofitting, but usually it's where there's space, surface parking lot. But retrofitting a zero lot line building, there's some significant challenges involved with that.
I did see a project in Vancouver that did drill underneath their building. Tim doesn't like to hear that because it's probably crazy expensive and his model not work. But yeah, I did see a 3-level. It was a bottom level of a 3-level underground parking garage, and they were drilling under the building. Watching them do it.
Yeah, I'm familiar with that technology. It's just not quite ready. Drilling in Ontario is very different than drilling in Vancouver, and that technology has been tried in Ontario, unfortunately unsuccessfully. So I think once we see advancements in drilling technology, that'll change that market significantly.
Here's a question that's pretty interesting and may not be able to answer it or not because it's too technical, but is the ratio where the footprint of a site versus height of a tower, would that sort of push geothermal not to work? I.e., if I had a small site with a 79-story tower on it, would we not have enough boreholes due to this small site to make the system work? And maybe this is like one of those hybrid options.
Yeah.
Maybe Bram?
Yeah, I touched on it briefly. You know, I think that was part of my response where it's like where geothermal may not work, and I want to highlight may, because you could always put holes in and get some capacity. But, you know, that example is a great one. You just need to look at if you're getting meaningful capacity and what's the cost to integrate that into whatever your conventional system may be. So there's no technical hurdle there. It just becomes a financial and practical hurdle. And you know, we've certainly seen small scale geothermal in big buildings for a specific purpose. But yeah, that would definitely throw the perform off, but it's not a technical challenge.
Okay, great. Yeah. And I think there's time for one last question, and this one's a good one. Have you seen developers building in redundancy and space for cooking water in the event of failure of a geothermal system?
Yeah, I can touch on that quickly, and then maybe the others have some input. So, you know, we've seen everything in between. We've seen geothermal implemented with full heating backup and full cooling backup, geothermal with just heating, geothermal with partial heating, cooling backup, and then just geothermal. You know, I'm sure there's other options in there, but and there's different. You know, I think it would be too long-winded to go into the who's, whys, and whens, but the answer is there's reasons for all of those things. It could be a load imbalance, a really heavy. Think of a data center that doesn't have any heating needs. You know, and even in Toronto or even in a cold climate, it's all cooling dominated. You could have a discrepancy in annualized loads and need something there. It could be you know, mission critical, and there's already a requirement for redundancy and how you address that redundancy, because you could address it with more holes or with conventional systems, or you're just looking to in the case where it's not necessarily redundancy, but maybe a lot of jobs are talking about deep carbon cuts, but not necessarily eliminating carbon, right? So you could look at some, you know, cross section of two lines that say, you know, if I drill this many holes, I can reduce 80% of my carbon, and then I have a bit of top up, if you want to call it that, in that case.
Yep, I'll add to that, Leona. I think the natural tendency is always to try to build in redundancy. My opinion is that you're gonna lose your benefit. I guess from a condo developer standpoint, you're gonna lose your benefit by trying to allow redundancy in your system. So my tendency is always to kind of push for total reliance and just manage that system. Some engineers push back on that. But I mean, Tim, we've done a project together, and it was totally reliant on geothermal, and Tim owns the bore field, so it's kind of his problem. So I wouldn't think he would suggest it if it was a bad idea.
Yeah, and I think, you know, to add to that, you know, between myself and our ownership team, we've done over 200 systems, and every single one of them is 100% geothermal. So we believe in that. And I think you have to ask the question, you look at redundancy, is it redundancy because you don't believe the system's going to work, or is it redundancy to provide some elasticity or a little bit of operating range? So we look at it through the lens of, we're going to own this for 30 years. There's a few things we're not sure about climate change, the impact on the energy profile, the loads, occupancy, especially if there's maybe some commercial or office space, it could be repurposed and the load profile could change. But those are minor, so that's where, to Brian's point earlier, having levers to push and pull, such as, snow melt, making sure the makeup air is integrated. And really it's about the overall integration of the geothermal and the mechanical. And we've passed the point now, you can't design those two things in isolation. It's a very, there's a lot of synergy in those designs. There has to be collaboration, and we have to make sure the building mechanical system allows us to control and manage and operate that bore field for 30 years without the use of redundant equipment, but using the equipment that's already in the building.
I think it's more a matter of those belts and suspenders, because it's even though it's an old technology, we haven't been really incorporating it into new buildings now, and people don't know about it, the performance 20 years from now, 30 years from now. So for example, a company like ourselves, we're not building in redundant systems, but we just allocated some space, for future equipment should the need arise. So that's the redundancy that we built or designed into our building that we just started construction on. So I think this is it. This has been a very great session. I was able to cram in a great amount of questions. Again, this is a recorded event. So again, by request to the organizers, you can get a copy of this. And thank you for joining us.
Thank you.
Bye to my fellow panelists.
Take care, everyone.